Okay, welcome to section 8.5. This is trigonometric or polar form of complex numbers. So we're just going to start with some basic information. To graph complex numbers in form a plus bi, we call the horizontal axis the real axis, and the vertical axis is going to be our imaginary axis. In example 1, we want to find the sum of the complex number 6 minus 2i, and before I continue, remember I is the square root of negative 1. You should remember that from Math 171. So whenever you see I, that's what it means, the square root of negative 1. And of course, if you were to come across I squared at some point, which could happen, since I is equal to the square root of negative 1, I squared is equal to negative 1. So sometimes we make that substitution. In example 1, we want to find the sum of 6 minus 2i and negative 4 minus 3i. Graph both complex numbers and their resultant. Remember, the resultant is basically the result after you've added them. Okay, so we're going to sketch our graph. Alright, so the x-axis is going to be the real axis and the y-axis is the imaginary axis. Okay, so we have 6 minus 2i, so we want to find 6 on the real axis, and we're going to go to negative 2 on the imaginary. Okay, so that puts us here. Okay, now we're just going to draw a segment that begins at the origin and goes to this point, and that's as far as we're going to draw it. And at this point, we put the arrow for the vector, and that represents the complex number 6 minus 2i. Now let's graph negative 4 minus 3i. So we go to negative 4 on the real axis, which is here, and negative 3 on the imaginary, puts us here. Do the same thing for that one. Okay. And then we have to get the resultant, so we just do that by adding the two complex numbers and graphing that result. So 6 minus 2i plus negative 4 minus 3i, just combine like terms. You're going to have 6 minus 4 is 2. Negative 2i minus 3i is negative 5i. So we're going to graph the complex number 2 minus 5i. So we want to find 2 on the real axis and go to negative 5 on the imaginary. And that puts us here. Okay, so the resultant, of course, is between the two original vectors. So this is our result there. So this was the resultant, and these were the two originals. Alright, next I've got some information that we need in order to continue the problems of this section. First are some important relationships. So we need to know that the x value is we can think of that as r times cosine of theta. Y is equal to r times sine theta. Now what is r? Well, r is the square root of x squared plus y squared. And we also have the fact that tan of theta is equal to y over x. So we already know this, you've used this before, but we're going to use it to help us with these problems. The trigonometric or polar form of a complex number, the polar form of a complex number x plus yi is r times cosine theta plus I times sine theta. This is sometimes written as RCIS theta. Alright. Converting from rectangular to trigonometric or polar form, these are going to be the steps that we'll use in a couple of minutes. We first sketch a graph of x plus yi, then find r using r equals square root of x squared plus y squared, and then find theta using tan theta equal y over x. So we'll come back to these steps in a moment. Example 2, we are asked to write 2 times cosine of 300 degrees plus I sine 300 degrees in rectangular form. Okay, so we're going to, basically when it says rectangular form, that's going to be the a plus bi form. So we want to first calculate cosine of 300 and sine of 300. And to do that, I'm going to go over to my unit circle. And here we are. Here's 300 degrees here. Alright, cosine I can see is 1/2, and sine is negative square root 3 over 2. So I'm going to make those substitutions. So that gives me 2 times cosine of 300 is 1/2, and I times, and then sine of 300 is negative square root 3 over 2. And then I'm going to distribute. 2 times 1/2 is 1. And then that's going to be giving minus I square root 3. And that's it. That's my answer. 1 minus I square root 3. So when they say write it in rectangular form, you need to compute the sine and cosine values here from the polar form, and then distribute the 2, and that gets you to the a plus bi form. And you can see that the real part a is 1, and the imaginary part will be negative square root 3. Example 3, we're going to go kind of in the opposite direction here. We want to write in polar form, and we're given negative 3i, or you can think of this as 0 plus negative 3i if you want. That way you can see a is 0 and b is negative 3. And of course, we're also going to be using this in terms of x's and y's, so you can think of this as x, the real part is 0, the imaginary part, y, is negative 3. And we have to write it in that polar form. Okay, so we're trying to write it as r times cosine theta minus I times sine theta. Okay, so that's what the polar form looks like. And I'm sorry, that should be plus. So r times cosine theta plus I times sine theta, that is our polar form. Alright, and to get it into the polar form, we're going to look back at the directions that we saw at the bottom of the previous page. So we start by sketching a graph of our complex number. Then we can find r using the fact that r is equal to the square root of x squared plus y squared. Then we can find theta using tan theta equal y over x. And once we have that information, we can put it into the polar form. So we first need to sketch a graph of the number that we were given. We need to sketch this negative 3i. Okay, so the real part is 0. So I don't have to go anywhere on the real axis. And the imaginary part is negative 3, so I come down here. Alright, so here is my vector. It goes from the origin to this point. Just like that. Okay, now this one is actually easier because in this example we're not going to need step 3 that's stated tan theta is equal to y over x, because with this being on the actual y-axis, we'll know what the angle is going to be. We'll be able to find theta pretty easily. Alright, but what else do we need? We need r. So r is the square root of x squared plus y squared. What are the x and the y again? Well, they're the coordinates of this point. 0 for the x and negative 3 for the y. So r is equal to square root of 0 squared plus negative 3. And you only put in the coefficient of I. Don't put I in the formula itself. Just put the negative 3 in. Square it. That becomes the square root of 9, and that gives us 3. So r equals 3. Okay, in this particular example, yes, you can look at this and you can see that theta is 270 degrees. Okay, but what if it wasn't so straightforward? Then you could go to tan theta equals y over x. So tan theta equals, our y is our negative 3 from here, and our x is 0 because we didn't go anywhere on the real axis. So we would have 0 for x. Now, of course, this is an undefined result, -3/0. So it's not going to work for us to go this route for this particular problem because we've got a vertical line here. So, but if for most problems, you would need to use this to help you find theta. Once you got to this point, you would next take tan inverse to solve for theta. Okay, but again, it's not going to work for this one, so we don't need it here. On this one, we can look at this and we know that theta is 270 degrees. Alright, so we are ready to write our polar form. So we're going to say we found 3 for r, so it's going to be 3 parentheses cosine 270 plus I times sine of 270 degrees. And that gives us the polar form. We'll do one more where you have to use this tan stuff over here to get it. Okay, so one more example. This one was not included in the notes that I scanned in for you, but we're going to write in polar form, and we're doing 4 times the square root of 3 plus 4i. So we need to first find, let's start by finding r. R is the square root of the real part squared, so 4 square root 3 squared, plus the imaginary part 4 squared. So that's the square root of 16 times 3, which is 48, plus 16. That gives us the square root of 64, and the square root of 64 gives us 8. So r is equal to 8. So we need that piece of information. And then to get theta, we need to solve tan theta equals y over x. Okay, y comes from the imaginary part of your complex number, so y is 4. And the reason for that is if you graph it, imaginary is the y-axis is the imaginary axis, and the x-axis is the real axis. So that means that this number is going to be the y value, this number is going to be the x value. 4 times the square root of 3 is going to be probably, let's see, square root of 3 is approximately 1.5. Multiply that by 4. So that's going to put us 1, 2, 3, 4, 5. Let me see if I can get a decimal approximation for that. So I want to do 4 times the square root of 3. I don't have my regular calculator with me today, so it's going to be about 6.5, roughly. So the real part is about 6.5. So right there, and then it's going to be up around here. Okay, so that's what my vector looks like for that number. So to solve for theta, we've got tan theta equals y. Y is 4. X is 4 times the square root of 3. We can simplify that as 1 over the square root of 3. Okay, now so if tan theta is 1 over square root of 3, we're not doing decimal approximations here though, so we got to think about this. Go to the unit circle. You're looking for an angle whose tangent gives us 1 over square root of 3. Okay, it actually happens here at 30 degrees, because if you do y over x, 1/2 divided by square root 3 over 2, that does give you 1 over the square root of 3. So theta is 30 degrees. So now we can write our polar form. We're going to have r is 8 times cosine of 30 degrees plus I times sine of 30 degrees. And that is our answer. 8 times cosine 30 plus I times sine 30. Alright, and that is what we're doing for section 8.5. So you've got an assignment posted. You can be working on these, and we will be ready to talk about 8.6 when I see you again on Wednesday. All right, thank you.